This is Engineering 120, section MO2, Matthew Goodenough, and this is my procedure and demonstration for Lab 4. So here we're going to measure the potential meter first. So I have it connect in center right, and this is my resistance I'm getting. And then we then move from center right to center left. I get 3.566 ohms. And then I move from center left to left right, and then I'll get a reading of 9.98 kilo ohms. So I did this for my calculations. I did mine before. It was 5.25, and then my values were 4.80 and 9.999. So then you take your potentiometer, your screwdriver, and you turn it slightly, just a little bit, and then we check the same readings again. My left right is 9.98, and my left center is 3.050, and then my left center right will read 6.95. So it decreased in value. It increased in resistance after turning your potentiometer just a little ways. And then now I'll go on to the series circuit, which is already built here. Let me just set it up real quick. So here I set up my resistors. My resistor 1 is going to have a value of 0.985 kilo ohms. My second resistor is going to have a value of 500 ohms. And my third resistor is going to have a value of 326.6 kilo ohms, or ohms. And then this is supposed to be 1 kilo ohm, but some of these have some percent error, which is okay. That's fine. And if I want to measure the resistance real quick, you just go to your multimeter and you go to ohms, and then you just connect your leads onto those resistors. As so, see, I'm measuring resistance in ohms and 0.985, and that's the value I get. And I do the same procedure for the other resistors. And now I will take the power source and measure the voltage across all these components. Now, so our voltage at our power source, we are going to get, I have to switch it to voltage. Okay, so my voltage, I get 7.5 volts, and then that is at our voltage source. And then when I measure across each resistor, the voltage is going to change. So our voltage at resistor 1 is 4.08, our second voltage 2.076, and our third voltage is 1.3451. So our voltage is decreasing, but our sum of voltage at 1, R2, and R3 are going to add up to our voltage source. Now I move on to current. For current, I have to break the circuit, which I will demonstrate below. Let me take these out. And then Okay, to measure current, we have to open the circuit. So the current has to flow through the multimeter. We must switch our comm links, and we must go to milliamps now. Now this system is going to measure our current coming from our source. If I plugged it in. So I plugged it in, we're getting 4.18 milliamps, and it should be the same throughout each resistor, so that should be flowing in each one. And I will just do one of the resistors for now, just to demonstrate it is flowing. So here it's going to flow through resistor 1. We're going to get the same reading of 4.1 milliamps, and it will be the same for the rest of the resistors as well. You just hook up your leads, you go from positive to negative, and then it will flow through. You'll get the same current here, here, and here, as shown in my results. So the currents are the same, and our power is decreasing once we use the power law, voltage times current. And that's the procedure for a series circuit. Now we'll move on to the parallel circuit. Now let me set that up real quick. It takes a little while, apologize. And then we switch our resistor 3 to a different reading. We're switching to a 5. It's supposed to be a 510 kilo ohm, and that will be for the resistor 3. Okay, I got it. So now I'm hooked up as a parallel circuit now. So when we take our measurements of voltage, the voltage should be the same throughout the circuit. And don't forget to switch your comm links for measuring current, because it will give you a stupid reading on voltage actually. And now my voltage source is plugged in. We're getting 7.15 volts, so when I measure across each resistor, I should get the same reading. And make sure you connect your leads right, else you won't get nothing. It's easy to put the wrong place. See, at voltage resistor 1, we get 7.5 ohms. Resistor 2, we should get the same reading. And we do get the same reading. And in my procedure, I got the same voltages in each one, because in a parallel circuit, the voltages within the circuit of the components, they share the same voltage as the voltage source, so it's equal to them. Voltage sources are equal. Now to measure current will be different in this case, because current changes throughout the circuit. Let me just measure that. See, as I measured the current of resistor 1 in our parallel circuit, it's 7.564. And I'll measure the last current I added in to save some time. So it's not like the series circuit where current stays the same, current changes in this instance. See, we have a decrease in current at our resistor 3. So as in my results, I had 23 milliamps, and by the end I had 1.442, and that's what I arrived with here as well. So our current is decreasing while our voltage stays the same in our parallel circuit. And our power is also varying due to the change in current. And that was it for the lab. That was all the procedure for the circuits on the breadboard. And thank you, and thanks for listening. And that was lab 4, and this is Matthew Goodenough in Engineering 120 MO2. Thank you. Bye.